So our next panel moderator will be Zoe from Phala. Zoe is the VP of Growth at Phala Network, and she will be introducing her amazing panelists.
Thank you. Perfect. Thank you so much, Lisa. Thank you also for SCRT to organizing this. And Phala, or our team from Phala, is a co-host and sponsor here, and very excited to have the second DCC day in the Web3 space. Cool. Yeah, thank you so much. Everyone who wants to listen to this very exciting panel, please take a seat or continue to networking outside so we get all the attention to our amazing speakers. I'm Zoe. I'm VP of Growth at Phala, and we are going to talk about a deep dive into DCC, Decentralized Confidential Compute. We will dive a bit more deeper into the infrastructure and all the technologies that are actually leveraged to provide DCC services. And I would like to welcome all the amazing panelists. We have Guy, CEO of Fhenix. We have Alex, CEO of SCRT Labs. Bowen, co-founder of Fairblock. And Hang, co-founder of Phala Network. Please get on stage. Cool. Yeah, we also already saw a great presentation from Hang about how to build a DCC co-processor. I think a lot of you guys are familiar with what SCRT is doing. Fhenix maybe as well, and Fairblock, we will hopefully learn a bit more about this today. I would like to start this panel a bit spicy, because all of you guys are building DCC services, right? Decentralized Confidential Compute. However, all of you, or at least 3 parties, use different technologies. We have trusted execution environments, also called secure enclaves, that we just learned that are used by Phala Network and also SCRT. But there's also FHE, fully homomorphic encryption. That's a security layer on the blockchain instead of off-chain. It's leveraged by Fhenix. And MPC, Multiparty Computation, where Fairblock is building a protocol based on. So let's get this started and say, why is your technology or the encryption or the cryptographic approach that you're using, FHE, MPC, or TE, the best for confidential compute?
Shall I start? Well, TE is definitely the best and only. No, I'm kidding. So TE is, again, trusted execution environment, hardware-based, and its advantage is that it has very low overhead. Computational overhead is comparatively very low compared to other technologies, so it works really fast. So the SCRT network, on SCRT network, the smart contract execution is comparable to any other Cosmos blockchain, so it's pretty fast and can do a lot of stuff. The downside is that you have to trust the manufacturer, right? So we are running on Intel SGX, and we are hoping that Intel has done their job well and that the privacy guarantees are there. And that's the downside, right? Because Intel processor is not open source, right? So if I compare it like to cars, I would say that TE is like a Volkswagen car. It's probably not like the super fast and not the fanciest out there, but it kind of does the job, right? It just takes you from A to B reliably, cheaply, and nicely. Yeah, and we can later talk about more differences. Yeah, so that's my take on TE.
Cool. Hang, what's your comment on this? And maybe also because in Phala we use mainly SGX, how we could maybe leverage other TE services.
Yeah, Alex make a really nice point. And as you know, the downside is if Intel has some bugs or it has even has some backdoor in the TE, then we're in trouble, right? So that's why recently there is a trend calling multi-proof. So not only TE, maybe TE is good for a lot of job, 80%, 70% of the job, but sometimes you need higher security, then why not to combine both TE and the other like other technologies together? They are not exclusive. We can use them together. So I think this is a very nice direction we're thinking about in the recent days.
Yeah, we are getting there later. Actually, we just wanted to pitch why TE is the best, but you already make a good transition. Before we get into MPC, let's hear about FHE, which is complete opposite because we have the security verification on-chain instead of off-chain. And Guy, you actually have a long career at Intel working with TE. So excited to hear why you are now switching to FHE for this confidential compute.
Yeah. So I used to manage Intel SGX ecosystem development. I was actually managing the team that used to go to the OEMs when there were issues with SGX. I used to pitch SGX, and I think SGX is really great. It's phenomenal, and it brings value in a significant amount of use cases. One of the trends that I've noticed is that for certain applications in the crypto space, the ecosystem does not want to trust the hardware. It wants to trust cryptography. This is a very cryptography-oriented ecosystem. Up until recently, FHE, fully homomorphic encryption, was considered this very novel encryption technology that enables you to do computation on data while the data is encrypted, which sounds a bit crazy because we were always taught that when you encrypt something, it's meaningless unless you decrypt it. But suddenly with FHE, we claim that we can do the computation on the data while it's encrypted. And the reason is that when we encrypt data with FHE, we still maintain the mathematical structure of the asset that we're encrypting. That enables us to do the computation over that encrypted data. So FHE really brings the security guarantees of data confidentiality, but with pure mathematics and without the need to trust the hardware. I will eventually mention that the end goal will be a combination of all technologies, but we'll leave this for your next question.
Thank you so much. Yeah, Bowen, you approached the confidentiality from MPC side. How are you doing this, and why do you think MPC is so powerful?
Yeah, I guess like from our side, we're thinking about it from a different perspective in the sense that like we don't want one person to control the decryption key. So to use the car analogy, I guess, it would be effectively like we don't want the same manufacturer to make all the car parts, or it's like a single point of failure in this case. What we do at Fairblock is we instead distribute this decryption keys in a way so that a majority of the validators on the network have to work together in order to generate this. And doing it this way ensures that no single party can decrypt the contents of your transactions, decrypt the underlying data without, I guess, the network agreeing to do this in the first place.
Cool. Okay, so we have the three areas, right? First of all, the off-chain, maybe not the fastest, but quite secure for TE on the hardware side. We have FHE, where we can do all the computation on-chain, which is also very strong and upcoming. And then multi-party computation, as we already say, to distribute the trust, right, for the confidentiality. Now, when you say, okay, this is what you're using, and Hang touched on this already, we are thinking more now, also starting this year, to combine these technologies, right? FHE can use TE, or TE can be also used for the MPC part. Why do you think is this so important? Why do we don't go with one technology or the other? And what kind of use cases will this enable? Because, I mean, TE is like Phala and Secret are around for a while, right? Why, when we now combine it with FHE, what kind of new use cases can we create? What do you think on this, Hang?
Yeah, actually, when talking about off-chain computation or computation in general, people are thinking about the verifiability. And when talking about verifiability, maybe the first word coming to our mind is zero-knowledge proof. Because, you know, zero-knowledge proof is just a mathematical way to prove something good is happened, and in this process, nothing is being manipulated. But it turns out there are actually, like, even for zero-knowledge proof, it's not perfect. And there are also other problems that zero-knowledge proof cannot complete. One example is zero-knowledge proof itself is a very, very complex technology. And if, like, building the zero-knowledge proof is kind of like building the CPU, because you also need to write the circuits. It's the ZK circuits, not the CPU circuits, but it's still circuits. And since everything is made by human, how confident we can be if there's a zero-knowledge proof generator or verifier? How confident can you be if you think this is right, implemented 100% correct? If there could be bugs in SGX, then there could also be bugs using ZK prover or verifier. In this case, if we're not confident about SGX or Intel CPU 100%, there's no reason you want to be 100% sure about the security of zero-knowledge proof. And it turns out there were some security researcher trying to audit the code from some ZK EVM projects, and they eventually found some bug just right before they have launch. It could not be 100% of the bug. So yeah, one point to make is zero-knowledge proof is not 100% secure. In order to make it secure, we need to have some backup. So we don't want to trust only a single program, a single ZK implementation. We want to trust maybe multiple ZK implementation, or use the other ways as the fallback. And TE itself is a very good fallback because whatever you can run in zero-knowledge proof, you can actually run in the TE in maybe simulation mode. And it's really, really cheap. You don't need to do any development or very, very minimal development. And with minimal effort, you get another layer of security. So this is why people sometimes call that 2FA, two-factor authentication. But it's more like a fallback for ZK. So this is one way how we can enhance the security of ZK.
Perfect. And to combine maybe TE with MPC, Alex, I know that you guys, Secret and Fairblock are working on some research projects. I don't know how much you can reveal on this, but what are you looking into combining TE with MPC?
So there can be different directions there. One direction that is kind of relatively straightforward is having multiple different kinds of TEEs on the network. Like right now we're working with Intel SGX, but what about the SEV from AMD, right? There's another TE that, if we have two of them, then even if one is compromised, then we're still good, as long as there is an MPC scheme between the two that would require them both to cooperate to sign the transactions or decrypt something. So this is one possible direction. Bowen, maybe you want to speak more about your ideas, because it's all like in early stages, so we're still thinking of different directions there.
Yeah, like the way I see it is that these various technologies are pretty complementary to each other. They all have like different security assumptions and different, sort of drawbacks to them. And by combining them, we get sort of the best of both worlds, where each other's downsides are like complemented by the other positive. So the way we were thinking about it was also like having a threshold network where some of the nodes are based off of TEs. And that way, you can be sure that the programs that they're executing are what they say they are, and that the keys won't be manipulated or the nodes won't collude with each other. Yeah.
Cool. Guy, from your perspective, because I find it so interesting that you actually switched your focus from the hardware side to FHE, why are you so passionate about FHE for specific use cases? And I don't know if you guys already look into combination with TE, but I would rather hear what for you enables FHE that TE cannot do for blockchain use cases.
Yeah, I want to up-level this for a minute, and talking from the people in the audience, I would say we probably have either developers or users. If you're a developer, all you care is that you can develop in Solidity and you can use your same tools. You don't necessarily want to start dealing with ZK because it's very, very complex. So you're looking at really the simplest way to start deep diving into that space. If you're a user, what you care is that the stuff that you're using is protected and that the cost is low. And that is where we're trying to mitigate everything that's been happening up until now. I would say what we have probably meets some parts in some respects. So some solutions that are out there are probably not Solidity-based or very complex. Others are more expensive. And the combination of the different cryptographies out there can really bring us into this baseline solution that we can deliver that meets and checks all the components that are needed. So in our case, we're using FHE because we believe that this ecosystem trusts cryptography. But we do understand that even with FHE, there are certain limitations that you would need in order to not maintain one key to split it using MPC, which is where MPC comes into place. We still believe that you need verifiability, which is where ZK comes to place. And of course, you need to run the MPC inside a trusted execution environment, which is another example. So for me, it's really about figuring out the bits and bytes that we can get from the different solutions out there, building this unified infrastructure, which can only be successful you bring it as a baseline. And I see excited to share some feedback here.
Okay, cool. So maybe we can summarize this also. I came across this quote I posted recently on Twitter, and I find it very nice. If you want to go quickly, go alone. If you want to go far, go together. Right? Maybe we can put this into like the combination of these technologies to actually provide very long-term decentralized confidential compute for the Web3 space, where we need to combine these security mechanisms.
Yeah, I was in other panels which weren't under the DECC brand name, and that was, more of like a bloodbath because each, component want to talk about how good their technology is. The reality is that we're still not in the place we need to be and level of confidentiality. We need to expose this. We need to make sure that people understand that confidentiality is a baseline infrastructure that is a must. And the best way to do that is really to partner together, to create more events like this, to communicate together so we can just make sure that everybody understand. At some point there will be a bloodbath. We're just not there yet.
I think it's a great point. I think today, well, in general, if we think about it, today all the blockchain space is very small, right? I mean, this whole industry's market cap is less than Microsoft, less than Apple, less than just one big company, writing software or doing mobile devices. And it's a huge industry, right? So right now we're very small, and very few people use it. If you think of it like a daily usage of all the blockchain, everywhere is like less than some third-rate news website in, here in Austin or some other small place, right? Relatively small place. No offense to Austin, of course. It's a beautiful city. So what I'm saying is we're still very, very early. And if we really want this industry to reach the billions of people that it's meant to reach, and if we really want people to move large parts of their lives to the chain and get the sovereignty and get the independence and get all the great things, no censorship and all that, we need to give those people data protection. You cannot live in a glass house. I mean, you can if you really want to and if you're, very beautiful, but you don't want all your messages and all your financial transactions and everything you do to be available to everyone all the time. It's just not sustainable. Like, it just won't happen. So that's why we need all kinds of different flavors of confidential compute technologies to be there, to work, and to build, for people to be able to really use the blockchain and benefit from this in a big way. And we're just in the beginning, and that's why I fully subscribe to what Guy is saying. There's no pie right now. I'm maybe too dramatic, but there's no privacy pie to divide. We need to build the pie, and then maybe we'll divide it. What I think will happen is it'll be so big, will be enough for us and for more and more players to come in and get a piece of that pie. So that's why, I think this is the spirit of the DCC day as well. It's like, okay, let's see how we can build things together, and what are the benefits of each technology in the light of, they address different aspects, and not which one is just absolutely the best, because there is no absolute best, I think.
So maybe a little bit of contradiction here. I think we're starting to see the narrative changing now. I think this industry had certain level of maturity. There was a problem of scalability. Layer 2s came into place. We had a problem of cost, and now data availability are reducing cost. The next problem to tackle is the fact that everything's out there in the public. We're starting to see that this narrative is starting to flow around. And for me, the next 2 years are going to be super exciting in that space, because we're seeing so many companies, so many different technologies, and this is just going to grow exponentially in the next couple of years.
Perfect. So let's talk a bit more about this adoption side, where you said we still need to build this pie. What can the audience do? What can developers do? Like people. I mean, let's talk mainly about developers because our target audience in Web3. As you guys heard already, none of these technologies can really work, or they can work on their own, but we are much more powerful and we can create the best confidential compute clouds if we combine MPC, FHE with TE. What are some critical thoughts maybe the developers can think of when they use a technology or when they start to build on something from a developer mindset? What would help us then to build also better tech? Hang, is this something you could comment on?
Yeah, sure. I think a few aspects. First is the interoperability of different kinds of projects. And I think for different kinds of projects, the methods could vary, but basically I think most of the projects available now are not targeting only a specific use case or a specific platform. And for example, for us, we built the off-chain compute co-processor, and we always say, okay, we are blockchain agnostic, although we build on top of Substrate, Polkadot tech stack, but we serve all the blockchains. We serve Ethereum, Base, Polygon, and even like Solana, Cosmos blockchains as well. So this is the capability side. I think most of the DECC projects share the same mindset. We're going to serve as many users as possible, and I think this is a very good start point. And another thing I just mentioned a little bit, maybe the other speakers can give better addition on that, is the mindset of collaboration, because there's no single solution that can solve all the problem at once. For example, we have like ZK again. I think maybe it's better to have a ZK people here so we can have a more direct chat, but basically like take ZK as an example. ZK is fantastic, but what if you run the machine learning model on ZK? It takes like maybe forever to execute. So that's where we need some kind of balance between ZK, the good technology, and also some other technology that can enable you to ship things faster. And one very good example is optimism chains. They are very nice in their design, and they have very nice tokenomic and mechanism design. But so far, the slashing is still not launched yet. But people are still happy to use that. And that's the power of let's push something to the market first. Let people to start use that, and then we can progressively improve that. So yeah, if we have the mindset to combine the multiple technologies together in the best way, then you can actually ship faster. And I think this is very important for most of the startup.
Cool. Let's make this as a closing thought. What else what critical thoughts can developers think about, or what would you like as an advice to give to developers for confidential compute usage?
Yeah, so I think the developers should think big. And when they start building their app, they should just try to imagine that it's becoming the next, Facebook or the next Ubisoft or the next Revolut, and it's being used by hundreds of millions of people in the world. And that everybody uses, and they use it all the time. And then the developers should think about how to provide some level of privacy, data protection, and they should start with that. And as soon as they realize that their app, be it a gaming app, a financial app like RWA, an AI app, a decentralized science, a decentralized social content, everything requires some sort of data protection in certain places, because it's not a toy for 3 people that they're building. They really need to be building something for hundreds of millions of people to use. And then the developers, when they think about this, they would realize that they need to protect the user data, and then they will start looking for solutions, and then they come to Secret, they find our great tools, they come to Phala, Fhenix, and dozens of companies out there, and they choose and mix and match and build. But I think it starts with understanding the need, and that they're not building, again, toys for very few, but infrastructure and apps for the next billions, to move them from this prison of Web 2 of those centralized corporations to this bright future of decentralization, freedom, self-sovereignty, and all the great stuff.
Thank you, Alex. Bowen, your final thoughts on this?
Yeah, I guess like one thing I would say is that we're all working on very different problems. They're all equally challenging in their own right. So I think one important thing is like building out in the open so that the industry can progress and at like a much faster rate. I think everyone's goal here is to provide this technology in like as easy of an experience to onboard for developers, and eventually like we might see a world where it's like very easy to chain all these tools together. At least like that's what we're trying to do here.
Amazing. Thank you so much. And Guy, your last closing thoughts.
Yeah, just to say that when you're thinking about an application, there are different ways to do it. Now you see that they're all in a certain level of maturity. It's quite easy to use, whether it's Secret or Fairblocks or Fhenix. And just try to think about how the application should really behave without the limitations that are being enforced today with transparency, because things that were considered unfeasible up until now are actually quite feasible in terms of encryption and confidentiality, and just should need to be used in your application.
Cool. Thank you so much. I would like to close it with this, and to summarize, decentralized confidential compute is a major component in all Web3 applications. For all the developers out there, start to think big, and let's go together to get far in Web3. Thank you so much, everyone.
Thanks, Zoe.